Hi, I'm Anjana Bhat. I'm a professor in the physical therapy department at the University of Delaware, and my research is focused on developing interventions for children with autism and in understanding their motor difficulties and how those impact their social communication skills and learning abilities. And this talk specifically is on the value of this new technology I'm working with called fNIRS, functional near infrared spectroscopy, to validate the effects of these interventions. So, children learn by observing others, by moving with others, by practicing skills with others. And the problems of children with autism are that they are not tuned to people around them, not aware of people around them, and their own bodies have a lot of incoordination or difficulty in terms of moving in complex ways that everyday activities require. So, for example, I'm looking at a data set of 16,000 individuals with autism, and parents have filled out what's called the DCDQ questionnaire, a motor impairment questionnaire that screens for motor issues in autism. And 86% of this sample of children with autism between 5 and 15 years have a significant risk for motor impairment based on this database. And what we know is the reality in terms of receiving services for motor issues is almost non-existent or significantly less compared to the problems they have. And so the overall call of this research is to say that motor issues are important to address, OTPT interventions are required and are not being offered at the same level as they need to be. So the work that I've done in the last 6 years or so has focused on the use of creative synchrony interventions. So the idea is to use engaging contexts. So what has been done in the standard of care or out in the community is called applied behavioral analysis. And the focus is to train the child to learn skills step by step by using a lot of reward and reinforcement. Most of the therapeutic activities are sort of promoting communication as well as academic skills. So it's a lot of seated play. Motor skills are not promoted in these activities as much. And so the interventions I have tested so far have looked at the effects of music or dance or yoga, and also in some cases movement with robots to promote skills, a variety of fine and gross motor skills. And so the question that we get is, okay, what do you see? And what we see is that when you engage in this sort of imitative, synchronous behavior with partners, you tend to have more smiles, you tend to have more verbalization, spontaneous verbalization. So you talk to your partner spontaneously, and you also show improvements that are motoric in nature. So improved imitation accuracy or more sustained synchrony with others during various motor skills. And the other question we get is, okay, but that might just be because you are going to their home and interacting with them. How do you know it is related to the key ingredients of your intervention? So how do you know that synchrony or coordination, that matters, and it's not just the fact that you are engaging with these people over 8 weeks. And so the NIH reviewers asked for more biomarkers of synchrony. And so the work that I'm doing over the last 3 years has looked for those biomarkers. And so what is the biomarker we are looking for using fNIRS or the near-infrared spectroscopy? The regions that we are interested in are called the mirror neuron systems. So again, people don't think that there are actual mirror neuron systems in humans like there are in animals, but those same cortical regions are present in humans as well. So the lateral cortices have what's called the inferior frontal gyrus, the superior temporal sulcus, which is around the ear, and inferior parietal lobule, so they are slightly above and posterior. And so these three regions together form the mirror neuron systems, and we are looking at activity in these regions across a variety of tasks. And so far we've looked at a reaching task, we've looked at cooperative building, so a building game, and a whole body synchronous sway task. And in general, across all these tasks, the conditions that we see children in are as they observe someone move, which is called watch, let's say, or observe, and solo conditions where they move on their own, and together conditions or synchronous conditions where they reach or sway or build together, and so they do it with a partner. And what we look for are brain activity patterns. So I'll talk about what we do in terms of analysis, but the measure is a measure of cortical blood flow. You get two signals, oxy and deoxyhemoglobin signals, and these are similar to the bold signal in fMRI. And the value of this over fMRI is the fact that you can move. In fMRI, you're lying flat in a scanner, but in a NIRS task, you could be reaching, you could be playing, you're face to face with people, which is not possible. And you're also, you could be moving your whole body in that position. In terms of data processing, I won't go into the details, but for any electrical signal, you have to filter. The additional step in NIRS is that you have to remove motion artifacts. They are naturally present, and we have some robust methods to remove those. And then we clump the similar trials. So watch trials are stacked, and the do trials are stacked, together are stacked. And then we come up with a single profile for each condition, for each child. And that is done for every channel. So depending on how many channels you have that many profiles for all the conditions. And then we sort of take an average based on our understanding. So there's, again, a lot of math that goes into identifying which brain regions are underneath these channels, and then we come up with an average across those channels that lie, let's say, under the inferior frontal gyrus or superior temporal sulcus or the inferior parietal lobule. And what have we seen in our results? So in our results across these three different tasks, we are seeing similar results when we compare children with autism to typically developing children. So one general trend is certain brain regions that are considered important social brain regions among the mirror neuron systems, the STS region. These are less active as compared to the typically developing children. So this is the typically developing profile, and these are children with autism. You're seeing a lot of red dots, which means the ASD group is less active as compared to the typical group. And then there are other regions that compensate. Certain regions that are not as important or not being used as much by the typical children are being used a lot more by the kids with autism. Another trend we see is that as the task becomes more complex, so as you move versus observe, or as you move with someone else, you tend to have some scaling in activation. You see this also in, this was one example. Reaching is one example. You see similar patterns in cooperative building. You also see it in synchronous sway. So here's an example of typical versus children with autism for building. You're seeing the solid lines tend to scale up. The solid lines are typically developing children. The hashed lines, as the task becomes more complex and more social demands are put on the child, there is less activation. So they seem to shut down, sort of. Versus in synchronous sway, again, similar findings. So in sway, we looked at solo movement, so each person moving or a child moving with a bar on the screen, so there's no social component, face to face with another person, or touching while moving face to face. And TD children again show this sort of scaling in activation for the frontal and temporal regions, versus the patterns of kids with autism are flat. Again, they also show this compensation in one area. So we think the biomarker is the lack of activation in these mirror neuron systems in particular regions. And what we want to do next is to use these NIRS tasks as pre and post measures, maybe the building task or the sway task, while providing a bout of intervention to children. So in the future, what I would like to do is a pilot RCT again in school-age children, by matching children across groups and randomly assigning them to two groups, either multimodal play, which is the play we've developed using a variety of themes, or just general physical activity. And not only do those standardized and behavioral tests that we did before and after in our previous RCT, but overlay the NIRS on top to see if we can shape the brain in any way by providing these more synchrony-based interventions. Stop at that. Thank you for this opportunity.